pollution of smaller drains that connected these water bodies, affecting the latter eventually. 26K Palanisamy. Further, due to encroachment and social forestry in the tank supply channels, foreshore and water spread area, water quality is affected by salt, sediments, nutrients and suspended organic matter, and in some cases, chemical pollutants. The transported sediments into the tank water spread area are responsible for the growth of algae and waterborne weeds. Palanisamy, 2006. Pollution of tanks, ponds and reservoirs has also led to pollution of groundwater. The latest available data shows that people in over 50% of the districts have access only to polluted water. The number of deaths due to waterborne diseases is increasing every year. 3.9 Climate change. The major impacts of climate change are likely to occur through water. Rainfall pattern is also likely to change in terms of distribution and intensity. While agriculture as a whole is expected to be mostly negatively affected, rain-fed agriculture, where tank irrigation is concentrated in particular, is expected to be impacted differently by climate change. Intergovernmental Panel on Climate Change, 2007. Rain-fed agriculture may have unexpected changes in its crop compositions and crop calendar, as the pattern and structure of climatic variables may change. These unexpected changes could sometimes be beneficial, when they are internalized. But mostly these impacts become cascading due to various socioeconomic changes taking place in these regions. Increasing commercialization, changes in gender and age composition of working farmers, lack of educated farmers in agriculture, increasing labor costs and declining labor productivity are some of the changes that complicate the situation on the ground. The cascading impact of all these changes accentuated by the climate variability seems to be driving the fortunes of the rain-fed farmers. More importantly, the farming communities and institutions are unable to foresee these impacts and adequately prepare themselves to face the challenges. In the context of increased temperatures, storage of water in subsurface aquifers assumes importance to reduce evaporation rates. And, tanks need to be connected to canal systems wherever possible in order to face water shortages and severe droughts. On the other hand, interlinking of tanks cascading becomes critical in the event of excess precipitation and floods. This is possible only with a comprehensive approach of integrating the three sources of irrigation in a river basin or watershed context. Rainfall forecasts should be effectively used to predict the likely nature of tank filling. Non-systems tanks should be converted into system tanks by linking the 27 tank irrigation in India. Future management strategies and investment options. Canal and river systems wherever possible, so that surplus water during heavy rains can be diverted to the tanks easily. The tank chain should be restored to facilitate the diversion of water from upstream tanks to downstream tanks. In all the future government spending programs on tanks, this should be made compulsory. While an integrated approach is necessary across the country, the requirements of the systems could differ from region to region depending on the changes or expected changes in climatic conditions. For instance, the need for an extent of desilting and the need for conversion of irrigation tanks to percolation tanks may vary from region to region. Palanisamy et al. 2010. Regular monitoring of climate as well as procuring hydrological data at appropriate scale is a prerequisite for sustainable resource management. Such information would help in identifying appropriate activities and investment in the context of climate change. For instance, partial desilting and increase in well density are observed to be more appropriate in order to cope with the impact of climate change in the future. Palanisamy et al. 2010. Similarly, tanks connected to canals, system tanks, are expected to provide more opportunities for improvement compared to non-system tanks. Palanisamy and Rosagrant, 1995 is quoted in Palanisamy et al. 2010. Generation of technical information at an appropriate scale is a prerequisite for policy planning in the context of climate change. Although there is considerable uncertainty in precipitation projections for future, it is likely that precipitation may increase in high latitudes and parts of tropics, and decrease in some subtropical and lower mid-latitude regions. More floods, droughts, decreases in agricultural and aquaculture productivity, displacement of millions of coastal dwellers due to sea level rise and intense tropical cyclones, and the degradation of mangroves and coral reef ecosystems are considered to be some of the likely consequences of climate change. Intergovernmental Panel on Climate Change, 2007. Indeed, heavy precipitation-related floods, storm surges and relatively higher temperatures have led to devastating consequences in recent years. Thus, the impact of the climate change is likely to be higher in rain-fed regions, where tanks are often the major source of water storage and groundwater recharge. Hence it is important to address how best the tanks could be restored, so that they could act as better water storage structures. The tank ecosystem-based benefits could also be revived, if tanks are restored with new vigor and commitment by the government and community. In locations where rainfall intensity is higher and where there 28K Palanisamy are not many tanks, it is possible to invest in new tanks after examining the financial viability of such investment. 3.10 Tank-based institutions. The important functions of any irrigation institution include water acquisition, water allocation and distribution, maintenance, decision-making, enforcement of decisions and conflict resolution. The traditional irrigation institutions have well-defined rules regarding the role and responsibility of each member of the tank and village community. The source of water to the tanks is mainly rainfall, and the tanks can be either isolated or in a cascade. When the tanks are connected to a nearby river or stream, reliable water supply is assured. The priority of the irrigation institution is water acquisition in case of river-fed and cascade tanks. The traditional tank-based institutions have well-defined conventions evolved over a long time, such as the opening and closing of sluices, allocation of water to various locations in the tank, command and allocation norms during water scarcity periods. Though based on customs and traditions, they are clear, specific, detailed and accepted by all tank farmers. Water management practices have been perfected over time by experience. The traditional institutions, based on their experience, involved the sequence of opening the sluices to have a minimum wastage of water. Over years, these institutions have disappeared or have become non-functional due to several reasons, such as splits among the farmer groups within the tank on the basis of caste, political affiliation, income status, education levels, etc. Conflicts in water allocation due to periodical failure of tanks in providing assured water supplies to fields. Poor revenue generation for regular maintenance of the tanks. Declining interest in tank irrigation by the younger generation farmers due to risk in farming.